Hello and welcome back in the lecture series where we are going to discuss about the IoT. It's nothing but your Internet of Things. And before that, just want to know about the how to design a circuit. What are the different components we require to design a circuit? As we already discussed about the power supply, resistor, capacitor, relays, LEDs, LDR, then IR sensor, PIR sensor, that is motion sensors, DC motors, servo motors, stepper motors, that already discussed in the previous sessions. Now we are going to just do some activities, the simple activities, but it is not related to the IoT, but simple activities which can be made to design some sort of circuit. So we are just going to deal with experiments with the electronics components, simple experiments with the electronics components. Before that, we just want to know the component, how to identify their values. So as we see the activity 1, determine the value of resistor. So as we know that there are 4 color bands are mentioned on the resistor, as already discussed in the type of resistor. So as we see here, we have a table that is color, that is black, brown, red, orange, yellow, green, blue, violet, gray, white, gold, silver, and no color. These are the color combinations which which are available on the resistor, out of which only 3 colors are represent as a value of that particular color and number and the multipliers, and the fourth one is the tolerance plus minus 5% for the gold, 10% for the silver, and 20% for the no color. And the multipliers is the third color, which indicates that the value is multiplied by 10 to the power 1 or 10 to the power 2 or 10 to the power 3, like that. We have till white is 10 to the power 9 and gold is 10 to the power minus 1 and silver is 10 to the power minus 2. And as we know that the number indicate as black is 0, brown is 1, red is 2, orange is 3, yellow is 4, green is 5, blue is 6, violet is 7, gray is 8, and white is 9. So as per the example here, we observed that the color, first color is red, then yellow, and then we can say that 10 to the power 3 is orange. So red indicates that the number is 2, then brown yellow is indicated as the number is 4. So it mentioned the number, that is red is indicated as a 2 and yellow is indicated as a 4. Third color is a multiplier, so 10 to the power 3 is a orange, and fourth one is a tolerance, the golden color is there, so that's why the gold color is there, that's why the tolerance is plus minus 5%. So the value will become 24 kilo ohm plus minus 1.2 kilo ohm per 5%, the 5% of that particular value. So through such type of activity, we can identify the value of resistors through color band, color coding. So as example, 2240 ohms, so the colors are red, yellow, and brown. 24 kilo ohms, the colors are red, yellow, and orange, as we see here. And 100 kilo ohm is brown, black, and yellow. This is a simple activity how to identify the resistor value. We can go for this particular activity and we can use this resistor to on and off the LED. But why we require the resistor in series with the LED? Because LED is a diode and LED have the specific conducting voltage. So if you will connect the 9-volt battery directly with the LED, the LED will get damaged or it may not use for the further purpose. So that's why we can connect a LED in series with a resistor with the battery. And if we need to on and off, so we have a switch. So as per the activity 2, connecting LED with the battery, resistor, and switch. So resource material are LED, resistor 330 ohm. Why 330 ohm? That we will discuss in the next series, next lecture. Because their conducting voltage, and as per the our formula, Ohm's law, V is equal to IR. So we can identify the value of resistor through V by I. So that is a point. Then switch, then battery is 9 volt, as we see here, 9 volt battery, conducting wire and jumper wires if required. So what we can do, we can connect a switch, positive terminal of a switch with the battery, 9 volt battery, and the negative terminal is connected with, means the terminal is connected with the 330 ohms of resistor, and the positive terminal of LED is connected with the resistor. So this is the simple way. And then the negative terminal of LED is connected with the negative terminal of a battery. So through which what we'll observe that we can just turn on the switch, then the LED will get glow. So turn on the switch to make the LED glow, and then turn off the switch, then LED will get off. So this is the simple activity we can do. But why 330 ohms, that we will discuss in the next series, next lecture. About the activity 3, connecting LED with battery, resistor and variable resistor. Whenever we have to identify the brightness of LED to increase minimum to maximum, so we required a pot. We can replace a switch by a pot or resistor, variable resistor. So we have resources as the battery LED, then resistor 330 ohms, then potentiometer 10k, and 10k will vary from 0 to 10k, then battery 9 volt, wires and jumper wire. So through which we can observe that the positive terminal of a battery is connected with the one terminal of a potentiometer, second terminal is connected with the 330 ohm resistor, and another terminal of a resistor is connected with the positive terminal of a LED. Then the negative terminal of a LED is get connected with the negative terminal of a battery. Through which simple connections, what we can observe that we can turn on the potentiometer knob, the left and then to right. Then we can observe the brightness of the LED increase and decrease as per the potentiometer knob will get increase from 0 to 10 kilo ohm, from move from one end to last end, another end. So we can observe the intensity or the brightness of a LED through this particular activity. So simple, this is the simple. Previously we just turn on and turn off the LED. Here we will just make sure that we can just value in the increase the intensity of a light. In the next activity, activity 4, connecting LED with a battery, resistor and light dependent resistor. Here we can observe that as per the characteristics of LDR, light dependent resistor, if the light will get emit or the absorbed by that particular resistance value of LDR, then we can observe the output on the LED. So we require a resource value material R, nothing but your LED, resistor 330 ohms, LDR, battery 9 volt and wire and jumpers. So again we can observe that the battery is connected with the LDR, and the another terminal of LDR is connected with the 330 ohm, and in the LDR the another terminal of resistor is connected with the LED terminal of LED. Then the negative terminal of LED is get connected with the negative terminal of a battery. So observe that the light dependent resistor can be used as a switch, as we already use as a switch, but here it's depend on the intensity of a light, atmospheric light. So the shine bright light on the LDR surface, observe the LED will glow. If the light will get available on that particular we can say that LDR surface, then the light will get LED will glow. Block light falling on the LDR surface by covering it with your finger and observe the LED will get turned off. So we can do such type of activity. We can reverse that activity. If the light will get not available, then the LED will get off, and if the light is available not available, then the LED will get on. We can also do same activity in a reverse manner. So this is one of the activity. In the first activity we will just connect a switch, then in another activity we will connect the potentiometer, and then third activity we are going to connect we are connected already the LDR, light dependent resistor. Next activity, we can observe that DC motor with the battery. We can just require the resource material, DC motor, battery voltage and a wire. So observe that the motor spin when the two leads of the motor are connected to the battery, and reverse the two wires. If we will connect the one terminal with the positive and second terminal is negative, then we can observe the movement of motor in one direction, and if we will reverse that wire, then observe the motor spin in opposite direction. So it can be like we can connect the wires reverse in the manner also, so that we can observe that the movement or the spinning of a motor in positive or the negative or clockwise or anti-clockwise direction. So this can be possible directly to connect the battery with the 9 volt battery terminal or the motor. Okay, because as we here we can observe that a motor can directly connected, DC motor can directly connected to the battery, but the LED cannot connected with directly with the battery. Here we have operate and control the speed of the motor. So we can just connect one 7805 like potentiometer, or we can say that we can say switch, then motor, then 9 volt battery, then connecting wire, and then we can say that propeller fan, to move the particular fan itself. So battery, then battery connection connected with that particular potentiometer, we can move the particular knob left to right or minimum to maximum, then we can get the observe the movement of fans from as the speed will get increase or decrease. Turn on the motor using the switch, control the speed of the motor using the potentiometer knob itself, so minimum to maximum, and if you want proper voltage to the motor, 7805 will get connected, okay, in place of with the series in series with this particular potentiometer and the battery. So this here we can control the speed of the DC motor. So this is one of the activity. Next activity can observe that turn on fan motor in touch sensor. The touch sensor, we have three terminal. We can see here the three terminal. One is the VCC, second is the signal, and third one is the ground. So the VCC get connected with the 9-volt battery, ground is connected with the negative terminal of a 9-volt battery. Then the middle terminal is get connected with the relay. Okay, relay also have three terminals. In one end we have a ground, 12 volt, and then the input. So we can connect the positive terminal of 9 volt to that particular terminal 12 volt. Then the input means the signal and the ground. Then the relay, whenever we touch the particular touch sensor, then relay will get work as a normally close and normally open. Now the one terminal is connected with the relay, have three connections. Okay, then center, then normally open, and normally closes. Now it's not connected. So we will connect the DC motor as a fan. So normally open is connected with the one terminal of a motor, and the second terminal of connection is get connected with the battery. So the touch sensor with your fingertip and observe the motor rotate. So by using touch sensor, we can observe the motor will get rotate. Remove the finger from the touch sensors and observe the motor get stopped. So this is one of the example how to turn on and turn off the motor or the fan by using touch sensor. So this is simple home automation activity itself. Next activity, you can observe that turn on buzzer if motion is detected. So we already discussed about the motion sensor, that is PIR sensor, that mentioned here itself. So motion sensor also have three terminal. One is the VCC, second is the out, and third one is the ground. Okay, so as we have VCC get connected with the 9 volt of positive terminal of a battery, then ground is connected with the negative terminal of a battery, and the middle terminal output is get connected with the one side of a relay. Okay, that is nothing but a output or the input of the relay. 12 volt terminal is connected with the 9 volt battery supply, and the ground is connected with the ground of a PIR sensor. Then 12 volt relay will have another like output, that is nothing but a normally closed, normally open, and normal connection. So that we can say that the buzzer have two terminals. One is get connected with the normally open, and second is nothing but the common. So common terminal is get negative connected with the negative terminal of a battery, and another terminal of a buzzer get connected with the 9 volt battery. Move the hand in a few minutes in front of motion sensor. So what will observe? If you move that particular hand in front of this motion sensor, then the input the signal will get given to the relay. The relay will get work as a normally open, normally closed. So if the normally it will get work as a normally closed, then the buzzer will get on. So remove the hands and observe the buzzer stop buzzing. So when the hands is like hands is we can say that move in front of that motion sensor, then we can observe that the buzzer will get buzz. So this is buzzing sound is get generate. So this is simple connection. Turn on the buzzer in motion if detected. Then this is another activity, turn on the pump of soil sensor. Soil moisture sensor, we can observe the wet and non-wet situation of a plant, or particularly we can say that if we need to on and off the water pump, so we can observe the wet and non-wet situation of a soil moisture sensor. Through soil moisture sensor we can observe that activity. So again, soil moisture sensor have three terminal. One is nothing but a VCC, second is nothing but a DO, and then third one is nothing but a ground. We can observe that here itself there are three connection. VCC is connected with the 9 volt, ground is connected with the ground of or the negative terminal of a battery. Also that negative terminal of a battery is connected with the one side of the relay as a ground. Okay, middle terminal of a sensor, soil moisture sensor, is get connected with the input to the one side of a relay, and then the 12 volt terminal is connected to the 9 volt terminal of a battery. Then the output of that relay is get normally open and common terminal. So normally open get connected with the one terminal of a water pump, and the common is connected with the, particularly we can say that the negative terminal of a battery. So dip the soil moisture sensor in a wet soil and observe that the water pump gets turned on, and dip the soil moisture sensor in a dry soil to observe that the water pump turns off. So this can be possible as we have such type of activity through which we can observe that the different circuit, how to design that different circuit. Same is here, as we have a raindrop sensor. If the raindrop, again three terminals are there, then VCC middle is a D0 and a ground, as same connections is there. So through the few drops on the water on the raindrop, sensors flat plate and observe that the water pump turn on. Wipe away the water dropped on the raindrop, sensor flat plate and observe that the water pump gets turns on. So this is one of the activity where we can observe that through the water pump. Then we have a IR sensor, that is fire sensor. So we can say that again this is the connection. Okay, when the bring the lighted candle close to the fire sensor, this is one of the fire sensor, so that observe that the buzzer starts making and buzzing the sound, and take the lighted candle away from that particular fire sensor to observe that the buzzer sound gets off. So this is one of the turn on and buzzer if the fire is detected. So fire alarm can be also designed by using simple circuitry. Next we can say that turn on the buzzer if the gas leakage. So MQ2 sensor is there, that left corner is the MQ2 sensor. Again this is this have four terminal. Now we can have this gas leakage sensor have a four terminal. One is the VCC, D0, A0 is also there, and a ground. So we can connect a ground with the negative terminal of a battery, VCC is the positive terminal of a battery, and if we connect as a D0, so then D0 is connected to the input terminal of a relay. Same connection, same as we already did in the previous activities. Then the normally close is connected with the buzzer, and another terminal of a buzzer is connected with the positive terminal of a battery, and the negative terminal of a battery is connected with the common terminal of a relay. So the turn on the cigarette or the cigarette lighter and blow the fire away. Then while keeping the light button pressed, bring the tip on the finger lighter, then close the gas leakage sensors. Observe that the buzzer gets making a buzzing sound. Then take the lighter away from the gas leakage sensors and observe that the buzzer stops buzzing. So this is the way to take the gas leakage. And then it is particularly we can say that automation system, but it can be observed by using Arduino, it can be observed by using the node MCU itself, and it can be observed by using the few of types of hardware. We can say that Raspberry Pi 3B plus or 4B plus itself. So this is a simple way to detect some sort of activity or design some sort of simple circuitry by using these components, as we have a component like resistor, capacitor, relay. Then we can say that we have another components also, that sensors, actuators. So these are the sensors, actuator, and other components we can use and we can design a circuit. So this is all about the making the activities and the use of the different components and design their own circuitry. So if you like this particular lecture, please like and subscribe my video channel. Thank you very much.